Now we will go to the power system and open general, and it will ask you about the phase sequence, and you will say ABC and not ACB according to the phase sequence you are working with. After that, we will find two very important things: the measuring point I3 phase and the measuring point V3 phase, because previously when we talked in the previous videos, you would find here that you are setting it up with a group of, but we didn't talk about the specifics of each one of them. So here, what will it ask you? Well, you will find it because you selected it there when you came to this one here. You selected it, and therefore it's just here for you to know what you chose, but you can't change it. After that, you get to the tracking part. Okay, the tracking part, if you come here like this, here it is. The tracking part comes and it tells you now that the values of the planes or the efforts you receive, what I'm going to say is applicable to the planes and applicable to the effort. So it tells you that there might be a deviation, and therefore this will give you in the readings of, okay, so what does this mean? It means, in my opinion, the whole idea is that I receive my reading in a certain way, and I take a set of, correct, so if the frequency I have, I take these samples every certain period of time, for example, depending on the fact that I know my frequency is in a certain way, okay, if the frequency changes, then my sampling or my sampling rate should also change so that I can reach the best form of the wave that I can use. So that even when I come to get the RMS and calculate my values, I calculate them in a correct way. So to ensure that we are consistent, improving the elections that get the election result from the rated frequency, there are two algorithms used in SIPROTEC. 5. First, what is election improvement? It reads the current or reads the voltage. What I'm going to say applies to the current, as I told you, and also to the voltage. And then it checks if you have it or not. Okay, very nice. All right, so it determines your current value. Okay, based on that, it calculates how often it should start taking what through something called resampling algorithm. This is effective for you as long as the frequency range is between 10 to 90 hertz, okay? The second thing is the fixed sampling frequency. What is this fixed sampling frequency? They said this method works specifically when it increases or decreases by half a hertz, like if you're moving between 55 and 65, it's okay with you. Is that clear? And thus, it only determines this. Based on that, the correction factor for your filter is changed. All right, if we come closer here to see how the process is going, quite simply, this is yours. This analog input determines your frequency, converting it from analog to digital with a sampling frequency of 16 kilohertz. Of course, to know how it takes a sample, it's 1 over the frequency. Is that clear? Very good. Then it performs something called correction for the magnitude and phase angle, and so on. After that, it divides this frequency by 2 and performs sampling with a frequency of 8 kilohertz. This 8 kilohertz then splits into 3 directions. One of these directions, if I divide it by 8, means 1 kilohertz. And this is for the distance and line differential protection, and so this is fixed. Then you have Fs over Y, meaning sampling frequency over Y. Who is this Y based on? It's based on what you or RD, what he will choose, meaning it will determine the frequency that you will track, which is how often you will track it. So if you tell him that this tracking system is active, he will determine based on the frequency he has how often to take a sample. He will divide the sampling frequency by a certain number to see how much he should take. This is for measuring the measured values, the phasor of the voltage, current, frequency, symmetrical components, and others. And of course, this frequency also comes into play here, and you have control over it, for example, from the word he has. He has control over it, exactly. Similarly, the 8 kilohertz also goes into the RMS values. The RMS values are also used to measure the RMS measured values, voltage, current, power, active power, and all that. Okay, the story of the tracking, okay. Are we going to use it or not? No. We are not going to use our tracking system anymore. Great. Then it comes to our part. And it asks you how many you have. Is it in the direction of what you are protecting or not? You immediately go to your manual. And let's go to our connection. Here it is. Of course, we need to know that in order to connect the CTs to the relay and the VTs to the relay, our reference must be the manual. The manual tells you here is the breaker, and here is your feeder, and you are protecting what is called the feeder. Therefore, you have made the star point towards the protected object. In this case, you take the CT terminals based on the fact that this CT has subtractive polarity. How did I know? Here is P1, and next to it is S1, or P2 next to it is S2. So, it tells you to take these terminals and connect them here to the dot point of the relay, which are points number 1, 3, and 5. Then you take their combination back to your neutral. If you make this connection, you should come here to the relay setting and tell it, yes, it is in the direction of the object I am protecting based on the connection we made. Do you have any change procedures? No, I have change procedures. Change procedures, if you want to read them, I will put this information in the table so you can access the website and read everything. This is the idea of reaching you. So, as I said, if you connect the star point to the access and the 3 terminals are connected to the access, you should read no, yes. If you are doing the opposite, taking those other terminals and connecting them to the input, then you must tell it no. If you come to the next word, here it is not all done like this. It has, isn't everything done like this? When you switch the generator operation to motor operation, it's natural that you swap 2 phases. So you need to inform the relay that these phases have been swapped. This means the reading you get here pertains to this phase or that phase, so it can perform its function correctly. Of course, we don't have this application, so we must not forget to do it properly. All right? Then you have, for example, if you want to perform a current check, or if you want to, let's say, forget about this part. Of course, any of these things I have covered over the years, but I don't want to dwell on them because we won't use them unless you have an application that requires it. No problem, we can explain it and then say what it means. However, if you want to know, I have written it here for you, the term current check, so you can see what current check means and understand how its logic works in your relay. But now I will focus only on the things we need. Okay, you have this, you set it from 1 to 10. So if you have, and of course the same applies, correction. This is set from 1 to 10. See? So if you have, and of course the same applies. The magnitude correction, when do you use it? It tells you to set it to a specific number, and thus it can correct each phase individually. This means if you have a tolerance or allowance for any error in the readings, you can compensate for it with this correction factor to ultimately achieve high precision measurements or very accurate values. Is that clear? Great. So this is what CT1, CT2, and CT3 are about. Of course, you can read it all here completely. Very nice. Okay, after that, you will find the broken wire detection for the current. All the functions after that are the secondary settings. We can explain them, but usually we don't use them. Is that clear? So what do we do with all of them? Okay, let's move on to the voltage. You will find here that it will ask you about, for example, let's assume we have 13.8 kilovolts. Or set it to high voltage, 130 kilovolts as you like. Here you have a voltage of 120 volts, which is, keep in mind, required from you phase to phase. You have the same idea we mentioned about the current, no tracking, no, I don't need it. Then you also have for the 3 phases, okay, so leave it at 1. After that, you have here the good sequence for the voltage and the miniature circuit breaker. In case you want to create a specific spare vision on the voltage, the entire explanation is available on the website, complete with logic and everything. Of course, this is for the current, and you will find this measuring point on the voltage. You will find an explanation for everything, even for very simple things. For example, let's see here. You have the supervision of the balance voltage, where it takes the phase-to-phase in the BBC, in the CEA, inputs them here, and checks the minimum against the maximum. If the minimum to maximum exceeds your set point or is less than your set point, and here the maximum of one of them, exceeds your set point, both are input into a timer. This timer then comes to tell you what you have, and of course you don't have a pickup for any function. It comes to tell you that you have a failure. Because the three are supposed to be balanced, right? So if it finds that one of them, for example, is above a certain limit and the smallest one compared to the largest one also exceeds its setting, it means that something wrong is happening in your secondary circuit of the VTE. So how does this function work? It's not just a single setting. You have a method where, as the maximum increases, you increase your restraint, similar to the differential. So I need the value of the minimum to the maximum. For example, if my maximum has increased significantly, then the value of the smallest one, compared to the largest one, must also increase. The two should not be close to each other, and both should be large. The smallest phase-to-phase voltage should not be far from the largest phase-to-phase voltage, so that it doesn't affect this method. At that point, it will definitely block the dependent function or trigger an alarm indicating there's an issue with the VT. Of course, this is different from the fuse failure function, which is another separate matter. So we have now finished the section related to the power system.